Namaste and welcome back everyone. Now as we have seen that Newton taught us about the projectile motion in 2 dimensions, we are going to see that what is the time of flight. Remember, we just need 3 quantities here. First is u, which is initial velocity. Second is sin theta cos theta component, which is trigonometric function, and the third one is gravity. So most of the things are very obvious here. Just the arrangement of these give us all the 3 formulas that we require here. So first of all, time of flight is equal to 2u sin theta divided by g. Now let's explore the range. Range is equal to u square sin 2 theta, means double of the angle, divided by g. And now the maximum height, which is u square sin square theta divided by 2g. So the easiest way to understand all that things is actually that 2 is moving in u sin theta by g. These are the fixed things. When you take that 2, it is on the front side in time. Now take that 2 in doubling the angle and u square in the range, and in the maximum height case we have u square sin square theta divided by 2g. So this is the way to learn that. You can go for the derivation in the note section. Now let's explore a little more applications of the laws of motion. To make the things easier, we work upon FBD. Something called as FBD means force and free body diagram. Force body diagram or free body diagram. In that we make a situational understanding and form the equations. We make the equations and we try to solve that, and we also can understand that what we can solve and what we cannot solve. So this is all about the equations. So let's understand what is the meaning of FBD. Take an example like a mass of weight m. Mass m is lying on a string and attracted by the gravity. So what actually happens? The gravity is pulling it down, means we write for the force ma, in place of a we write g. So the down force becomes weight force, which is mg. Now there is an upward force which is counterbalancing that downward force, that is called as tension. The tension force is opposite force. Now this opposite force came from the third law of motion, third law of Newton's motion, which is action and reaction. So normal force or T here is equal to mg. So this is the first equation, and this is the simplest way in which we can find the tension force and mass. Now about the second application. In the second application we determine that something like a body is moving in a plank, like you can see here. In the plank area, when we try to make it happen, what actually it gives us? We get cos theta and sin theta components. When we get cos theta and sin theta components, it becomes drastically increasing, as you can see in the figure here. And figure out that what actually happens. It is well explained that we know that the forces in the cos theta means the resultant and the base. The forces on the sin theta means perpendicular and the resultant. So we counterbalance these equations to understand the motion and understand the acceleration, and sometimes we can also calculate the mass. This becomes very interesting and important factor. You can have so many practice problems in the question section, and you can practice all these problems. For now we are going to explore more things in the motion, because this is physics in motion. So to learn all that interesting and encouraging things, we are going to explore the friction, which is also a kind of force, in the next section. Stick with me, take care, God bless, and namaste.